Okay, now next is refraction through prism. You can see in this diagram, ABC is an prism. Then you can see here, this is an incident ray of light, which is shown here. You can see here, this is an incident ray of light which falls on the surface AB, which is refracting surface, and at the point of incidence we have to draw a normal. So this n dash is a normal at the point of incidence. Now we know that ray of light is traveling from air medium to glass medium. It bends towards the normal. So this ray of light is an refracted ray of light. So we have to draw another normal at the refracting surface AC, m dash, and the ray of light again travel back in the same air medium from the glass. This ray of light is called as emergent ray. Then the point of intersection of these two refracting surfaces AB and AC, there is an angle formed here. This is an angle of prism. Angle of prism. So when a ray of light passes through the glass prism, it gets bent twice at the air glass interface and glass air interface. The emergent ray is deviated by an angle to the incident ray. This angle is called as angle of deviation. So it is the angle between the incident ray which is produced forward and the emergent ray which is produced backward. You can see here the angle which is shown in blue color. This is an angle of deviation. Okay, the next one is dispersion of white light by glass prism. So when a white light is made to pass through a glass prism, this white light splits into 7 different colors: Vibgyor, violet, indigo, blue, green, yellow, orange and red. This band of colors which are obtained on the screen is called as spectrum. So see here, it splits into when a white light is passed through a glass prism, it splits into band of colors called spectrum. This is called as dispersion of white light. The spectrum of white light has the colors violet, indigo, blue, green, yellow, orange and red, which is Vibgyor. The red light bends the least and the violet bends the most. So this is what the dispersion of light. So it is shown here, see, and a white light passes through a prism. So all 7 different colors are shown here. The next one is the recombination of spectrum of white light. Now what actually is this recombination of white light? You can see in the diagram there are 2 prisms here. One is erect prism and another one is inverted prism. So only white color and red colors are shown. In between white color and red color other colors are present which are not shown here. So when a beam of white light is passed through a glass prism, it split up into its component colors. When these colors are allowed to fall on the inverted glass prism, it recombines to produce white light. So here when a white light passes through one prism, it splits into 7 different colors. The white light splits into 7 different colors. And that white light, when it is made to pass through another inverted prism, these all colors will recombine to form a white light back again. So this is what recombination of spectrum of white light. The next one is rainbow formation. Some application of refractions we are going to discuss. First one is rainbow formation. So a raindrop is shown here. When a ray of light passes into when the sunlight passes into the raindrop, internal reflection, total internal reflection take place and a refraction take place. So see here, a rainbow is natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by water droplets present in the atmosphere. So their dispersion is taking place with the help of raindrops. So raindrop is acting like a prism. The water drops act like small prisms. They refract and disperse the sunlight, then reflect it internally and finally refract it again when it comes out of the raindrops. Due to the dispersion of sunlight and internal reflection by the water droplets, we see the rainbow colors. So here in the rainbow formation, through the drop, first refraction occurs when light travels from air to drop, refraction occurs. Then reflection occurs, internal reflection. Then again refraction occurs from the raindrop to the air, and due to which the 7 different colors of white light present in white light are seen in the form of rainbow. So this is a rainbow formation. Next one is atmospheric refraction, that is apparent position of star and the real position of star. So why the star twinkle, or why the position of star will change? Say atmospheric refraction is due to the gradual change in the refractive index of the atmosphere. The refractive index of the atmosphere gradually increases towards the surface of the earth because of hot air above is less dense than the cold air below. So the light gradually bends towards the normal, so the real position of star is different from the apparent position. So as the height increases above the earth crust, the density of air will decrease and temperature will be more, and due to which the light is traveling from rarer medium to denser medium when it travels towards the earth, and it bends as the ray of light is traveling from rarer to denser medium, it bends towards the normal, and when you produce that ray of light in backward direction, you will see the apparent position of the star. Okay, the next one is twinkling of stars. Next atmospheric refraction application. Why do stars twinkle? The twinkling of stars is due to the atmospheric refraction of starlight and due to the change in position of stars and the movement of layers of the atmosphere. So the light formed from the star is sometimes brighter and sometimes fainter, and it appears twinkle.